Beneath the streets of London, under its bridges and its famous river, a city of 9 million people produces something nobody wants to talk about. And for more than a century, they didn't have to, because a Victorian engineer buried it for them. But by the early 2000s, what Bazalgette built was no longer enough. Not even close. This is the story of how London confronted a crisis hiding in plain sight and built one of the most complex pieces of underground infrastructure in human history to solve it. 25 kilometers of tunnel drilled through the geological heart of one of the world's busiest cities at a cost of £4.5 billion for a problem that the very city above it had spent a century and a half ignoring. Let's explore how London built a £4.5 billion super sewer for 9 million people. Let's go back to the summer of 1858, when London was the largest city in the world. Back then, the city's population had more than doubled in 50 years to over 2.5 million people. And with that growth came a catastrophic failure of sanitation. Raw sewage flowed openly through the streets into the River Thames. The river was, in every practical sense, an open sewer. Then, in the scorching summer of 1858, temperatures averaged 35 degrees Celsius. The Thames baked. The human and industrial waste coating its banks created a stench so overwhelming that it became known to history as the Great Stink. The smell invaded Parliament itself. Curtains inside the Houses of Commons were soaked in chloride of lime in an early attempt at air freshening. But none of that worked. This unhygienic situation resulted in 3 separate cholera outbreaks that had already killed tens of thousands of Londoners. During that period, the disease was thought by most scientists to be spread through foul air. But one London physician, Dr. John Snow, stated a different theory, that cholera was waterborne. Sadly, he was largely ignored, right up until the Great Stink made ignoring the problem impossible. Parliament moved fast. On August 2nd, 1858, they passed legislation giving the Metropolitan Board of Works full authority and £3 million to sort out London's waste problem. The man they hired to do it was their chief engineer, a slight, precise, relentlessly hard-working man named Joseph Bazalgette. Joseph William Bazalgette was born in Enfield on 28 March 1819. He was the only son of a retired Royal Navy captain, trained as a civil engineer, and had already survived one nervous breakdown brought on by overwork before he was even given the most important project of his life. He reviewed 137 proposals before settling on his own. His master plan comprises a network of 82 miles of enclosed underground brick main sewers running parallel to the Thames, connected to over 1,100 miles of street sewers, all draining eastward by gravity to pumping stations that would discharge well away from central London. The whole project would require 318 million bricks, with thousands of laborers digging the tunnels largely by hand. The demand for workers was so intense that it drove up bricklayers' wages by 20%. Bazalgette insisted throughout on using Portland cement, which at that time was one of the strongest and most water-resistant materials available, even when accountants pushed for cheaper alternatives. Interestingly, Bazalgette designed his tunnels in the shape of an upside-down egg, wide at the top, narrower below, which could withstand the weight of the city above and handle far more flow than the system would immediately need. His engineers told him to size for the population that existed, but he sized for the population he believed would come. Construction ran from 1859 to 1875. By the end, Bazalgette had spent £6.5 million and created 1,300 miles of sewers beneath London. Cholera was effectively eliminated from the capital, not because anyone understood that cholera was waterborne, but because Bazalgette had accidentally removed the contaminated water from the equation. Dr. John Snow was vindicated, though he died at the height of the Great Stink before knowing it. Bazalgette was knighted by Queen Victoria in 1875. He died in 1891. Above his Thames Embankment monument are inscribed the Latin words, Flumini vincula posvit. He put the river in chains. His sewer system still runs under London today. Bazalgette's sewer system was built for a city of 4 million people, but by 2001, London had reached a population of 9 million. And the problem wasn't just population growth, it was the way the city had changed beneath the streets. London's Victorian sewer system is what engineers call a combined system, because rainwater and sewage flow into the same pipes. In Bazalgette's day, much of London was green, rain soaked into the ground. But over the past 150 years, the city has paved over gardens, courtyards, and open land. Today, when it rains in London, the water hits tarmac, tiles, and concrete, and goes straight into the sewer. The result by 2011 saw London's sewers overflowing more than once a week. As little as 2 millimeters of rainfall, barely a drizzle, could be enough to trigger a discharge. And when the system overflowed, it didn't overflow into anything pleasant. It overflowed directly into the River Thames, untreated every single time. Each year, an average of 39 million tons of storm sewage, a mixture of rainwater and raw sewage, is discharged directly into the tidal Thames. Not into treatment works, into the river. The bacteria that broke down the sewage consumed oxygen from the water, suffocating fish. The river that Bazalgette had cleaned was being poisoned again, one storm at a time. And London was legally obligated to do something about it. In 2001, Thames Water, the Environment Agency, DEFRA, and the Greater London Authority sat down to confront the problem. Together, they launched the Thames Tideway Strategic Study, an investigation into what it would actually take to clean the tidal Thames. 4 years later, in 2005, the study published its findings. The conclusion was uncomfortable. They had evaluated a wide range of options: green roofs, permeable paving, sustainable urban drainage, separating stormwater from sewage in the streets, and upgrading existing infrastructure. Every option was assessed on cost, feasibility, and effectiveness. Their conclusion was to build a deep-level tunnel to capture, store, and transfer the combined sewer overflows before they reach the river. Not everyone agreed. A 2006 report commissioned by Ofwat strongly recommended further studies of laying separate stormwater pipes across London. Ofwat itself noted in 2007 concerns about the tunnel's value for money. Professor Chris Binney, who led the original 2005 study, would later argue publicly that the project was a waste of money. Critics argued that London could have spent the same money on green infrastructure, permeable surfaces, swales, water butts, and achieved a better long-term result more cheaply. The debate continued for years, but the scale of the environmental problem, the legal obligations, and the growing urgency of London's population growth kept pushing the tunnel solution forward. In 2014, after more than a decade of study, consultation, and controversy, planning approval was granted. The estimated cost at the time of approval was set at about £4.2 billion. That same year, the government and Ofwat finalized a financing structure unlike anything the water sector had seen before. One of the most consequential decisions made in the entire project wasn't about engineering. It was about money. Thames Water, the company responsible for London's water and sewage, was too financially exposed to carry a £4 billion construction risk on its own balance sheet. If the tunnel had been delivered through Thames Water in the conventional way, the costs and risks to customers could have been substantially higher. The solution was a new model. A completely separate company, Bazalgette Tunnel Limited, which would trade under the name Tideway, would be established specifically to finance, build, maintain, and operate the tunnel. It would be regulated by Ofwat, protected by a government guarantee against catastrophic cost overruns, and funded by private investors who would be repaid over decades through a surcharge on Thames Water customers' bills. On 3 November 2015, Ofwat awarded the license to Bazalgette Tunnel Limited. The weighted average cost of capital was set at 2.497%, significantly lower than if Thames Water had funded it conventionally. The surcharge to each Thames Water customer's bill would not exceed £20 to £25 per year, calculated at 2014 to 15 prices. That figure, roughly the price of a takeaway dinner per year, would remain within range even as the project ran on for a decade. Tideway also pioneered something else: green financing. By 2017, they had begun issuing green bonds and loans, eventually raising more than £2 billion this way. Their green bonds were awarded dark green status by S&P Global Ratings, the highest possible rating. The financing model was so successful that it has since been adopted as the blueprint for major UK nuclear power station megaprojects. Construction began in 2016 at more than 24 sites, stretching from Acton in West London to Abbey Mills Pumping Station in Stratford, East London. The first phase of work was the shafts. More than 20 deep shafts had to be sunk across London to provide access points and interception chambers. Some of these shafts were as wide as the dome of St. Paul's Cathedral and went down between 20 and 60 meters. In November 2017, the first tunnel boring machine arrived in London, transported by barge along the Thames. Her name was Rachel, named after engineer Rachel Parsons, the founding president of the Women's Engineering Society and a former resident of Fulham. 6 TBMs were used in total. Each weighed 1,350 tons and stretched 147 meters in length, the equivalent of 12.5 double-decker buses laid end to end. They were manufactured by Heron Connect in Germany and transported to their launch sites in sections, lowered into the ground through the construction shafts, and assembled underground. Tunneling began in 2018. It ran 24 hours a day, 7 days a week, for 4 years. The tunnels had to pass beneath Tower Bridge, live underground lines, gas mains, water pipes, and the foundations of buildings that have stood for centuries. One challenge was unique to this project: deoxygenated ground. In certain sections of the route, the soil itself contained so little oxygen that workers needed special breathing equipment to carry out maintenance on the TBM cutting heads. The pressure conditions in some parts of the tunnel required hyperbaric interventions, working under compressed air, which required special dispensation from the health and safety executive. The tunnel was built in 3 sections. The western section, 7 kilometers long, ran from Acton Storm Tanks to Carnwath Road Riverside, delivered by a joint venture of BAM Nuttall, Morgan Sindall Infrastructure, and Balfour Beatty. The central section, 12 kilometers long, ran from Carnwath Road Riverside to Chambers Wharf, delivered by a joint venture of Ferrovial Agraman UK and Lang O'Rourke. The eastern section, 6 kilometers long, connected Chambers Wharf to Abbey Mills and was delivered by Costain, Vinci Construction Grand Projet, and Bachy Solitange. Lastly, system integration was handled by Amy. Around 95% of all excavated material, more than 4 million tons, was transported by barge along the Thames. And that single logistics decision prevented more than 250,000 truck journeys through central London. In total, the project employed almost 25,000 people and logged more than 40 million working hours. On the 5th of April, 2022, TBM Annie broke through, completing the final section of primary tunneling. It was a milestone that had taken 4 years of continuous underground work through a global pandemic that cost the project an additional £233 million and pushed the completion date back by more than a year. By autumn 2023, the secondary lining, which is the reinforced concrete inner skin of the tunnel, was fully completed, and barely a year later, all heavy civil engineering above ground was done. 8 years after construction began in May 2024, deep underground at 66 meters below the streets of East London, a 1.5 meter thick reinforced concrete wall that had separated the new Thames Tideway Tunnel from the existing Lee Tunnel was demolished. That single act of demolition connected the 2 tunnels and formed the London Tideway Tunnel System, a combined storage and transfer network with a capacity of 1.6 million cubic meters. On 23 September 2024, London experienced heavy rainfall. For the first time, the storm flows that would have spilled into the Thames were instead diverted into the new super sewer. 4 of the 21 connection valves, operating like giant gates, were open, capturing 589,000 cubic meters of sewage in a single 24-hour period. Then, on Valentine's Day in 2025, the final 21st connection was made. The super sewer was fully connected. The last link joined the original Victorian sewers, which had stood since Bazalgette's time, to the 25-kilometer tunnel running beneath the city they helped build. 5.5 million tons of sewage had already been kept out of the Thames since the first connections were activated. On May 7, 2025, King Charles III officially opened the Thames Tideway Tunnel at a ceremony at Blackfriars. And in August 2025, the tunnel was declared fully operational. In the first full year of the sewage system operation, it had captured 18.4 million tons of sewage that would otherwise have entered the River Thames. That is the equivalent of filling Wembley Stadium 4.5 times over. The system had previously discharged into the Thames on average 60 times a year. Now, that figure is expected to fall to fewer than 5 times per year, and only in the most extreme weather conditions, such as 3 consecutive days of solid rain. An estimated 95% of the sewage spills that once plagued the Thames are now being stopped. The The tunnel is designed to last 120 years and incorporates climate change projections into its specifications. The Channelsea River and River Lee, connected via the Lee Tunnel, operational since 2016, already show good to excellent water quality as a result of the earlier phase of the project. In the summer of 1858, the smell of London's failure forced Parliament to act. Today, in the streets above a 25-kilometer tunnel drilled through the geology of one of the world's greatest cities, you would not know anything had changed. The Thames flows, the bridges stand, the city moves. But 67 meters below, where no one can see it and almost no one thinks about it, the engineering that keeps a city of 9 million people livable is finally, for the first time since the Victorian era, fit for purpose. Bazalgette built for 4 million. His successors built for 9. And somewhere in the logic of that number, there is a question every growing city on Earth will eventually have to answer. What does the city beneath the city need to look like for the city that hasn't been built yet? London answered it. It took 160 years, 4.5 billion pounds, 25,000 workers, 6 tunnel boring machines named after remarkable women, and more than 40 million hours of labor underground. But the river is getting cleaner. Thanks for sticking to the end of our video on how London built a 4.5 billion pound super sewer for 9 million people. Until next time.